Hi guys, welcome to Kinemarc. In this episode we are going to solve actual questions on the Math 151 Algebra exam using our calculator. The key to passing this exam is speed. So we want to make use of our calculator to give us that speed. These questions are taken from some of the past questions available around. Question 1, find the values of x and y if 3x plus 2y minus. Okay, so you first have to identify what the question is about. This is about equality of complex numbers, right? So we know that for two complex numbers to be equal, their reals must be equal to their imaginaries. So here we take the imaginary sides of our complex number on the left hand side. The imaginary parts are those that are more or less factors of I. So 2yi and negative xi, these are the imaginary parts, and then the real parts are 3x and then 5y. So we know that our reals 3x plus 5y should be equal to the real side. It should be equal to 7, and then 2y minus x, 2y minus xi should be equal to 5 because that's the imaginary side. So we quickly use our calculator. I hope you know how to use your calculator to solve equations. So you go to mode and then mode 5, that's for equations, and then simultaneous equations in two variables, that will be number 1. So number 1, so 3x, we take a to be the a column as the factors of x or the coefficients of x, b for coefficients of y, and then c for our constants. So 3x plus 5y equals 7, and then negative x, so negative 1x, and then plus 2y equals 5. Enter. So we expect our x to be negative 1 and our y to be 2. As you can see from here, we don't have any x to be negative 1 and then y 2. So the answer is none of the above. So none of the above. Here, which of the following is the root of negative 1 plus I? Now the key to solving questions involving roots is that quickly convert your complex number into polar form, and then you know that for a complex number rei theta to any exponent n, it's simply rn and then ei theta n. Check our previous video for an explanation of this if you haven't done so. So quickly, what we do is to find, when we've gotten the magnitude of our complex number, we raise the magnitude to n, and then when we've gotten the angle, the argument, we multiply that by n. Now because we are finding the root of our complex number, it's going to actually have multiple versions. We are going to have multiple versions of that complex number, so we will explore how we can find these other versions of the complex number. They are all roots of the same complex number. So let's first get it down with find the argument and then find the magnitude. So you quickly convert our, we go to complex mode, mode 2 for complex, and then negative 1 plus I, we convert this to a complex number. So complex, and then Euler form, it's already a complex number, we convert it to polar form. So our magnitude is square root of 2, so root 2 raised to the power r, n is 1 over 3, and then our argument is 135 degrees. So our angle is 135 degrees. So we're going to multiply by that by n, which is 1 over 3, so 135 degrees over 3. So 135 over 3, 135 divided by 3, this is going to give us 45 degrees. So our argument is 45 degrees. Now here's the trick. When you have, for cube roots, you know, this is exponent 1 over 3. Now for exponent 1 over 3, we are going to add pi on 3 to our argument. We keep adding pi on 3 to our arguments to explore the various roots of our complex number. Just stick with this trick, it works. if we were to find the square root, or this complex number was raised to the power 1 over 2, we'll keep adding pi over 2 to our argument. Now we've been given root 1 over 3, so we are going to keep adding pi on 3 to our 45 degrees. How? Because we are in degrees, we need to know what pi on 3 is in degrees. So like we've mentioned in our previous video, we can convert pi on 3 to degrees by simply entering pi on 3 radians. So number 2 radians, and then we have it to be 60 degrees. So we will keep adding 60 to our 45 degrees to explore the other versions. So 60, our argument is 45, so we add 45 to 60. 45 plus 60, 105. We don't have any angle 105 here. If we had an angle 45 degrees here, we would have picked that angle. We know that cube square root to the power 1 over 3 gives us 2 raised to the power 1 over 6. So a is even out of the equation. We are looking for 2 raised to the power 1 over 6. So it's either B, C, or D according to the magnitude. So now we need to focus on the angles. Which of these angles is correct? So 45 degrees is our base argument, but it's not here. So we are trying to find the other versions of this complex number, the other roots. So we add our 60 degrees or our pi on 3 to our 45 degrees, 105 degrees. It's also not here. And then we add 60 degrees again, which is our pi on 3. And then we get 165 degrees. So we have 165 degrees here. So D is our answer. Now, moving on. Express sine 3 theta as powers of theta. So we have ideally how you'd solve this is to use your knowledge of trigonometry. To use your knowledge of trigonometry to express sine 3 theta as powers of sine theta. But with our calculator, we can move very quickly on this. So what you do is to pick any theta, okay? Pick any theta. So I really like to pick 12 degrees, even 12 radians. It doesn't matter. Just pick any number for theta. And then you find sine theta. You know, all your answers are in powers of sine theta. So this is sine theta raised to the power 1. This is sine theta raised to the power 3. This is sine theta raised to the power 3 again. So sine cube theta is sine theta raised to the power 3. So then we are going to find sine theta with the theta we have here as 12. We are going to find sine theta, which is sine 12. I don't care here. I don't care if it's in degrees or radians. And then I'm also going to find sine 3 theta, which is sine 36. And then the meaning of this question is that sine 3 theta is equal to one of these, because you're expressing sine 3 theta as powers of sine theta, meaning the powers of sine theta or the combinations of the powers of sine theta will give you the same value as sine 3 theta. So we are going to, so in essence, sine 3 theta is equal to one of these. So with the theta we've picked, and with the sine theta we've picked, and with the sine 3 theta we've picked, we are going to let our calculator tell us which of these is true. So what you do is to save sine 3 theta, the value of sine 3 theta, which is sine 3 times 12 or sine 36. Sine 36. We will save this. So to save an answer in one of the memory spaces, we have many memory spaces: A, B, C, D, E, F, X, and Y. So to save this in A, we are going to say shift to access STO. STO is for store. RCL is for recall. If you want to recall one of the values stored in these memory spaces, use recall. If you want to store a value into one of the memory spaces, use store. So shift recall will access store, and then we press A. So shift store, and then we press A. So now sine 3 theta or sine 36 has been stored in our memory space A. Now just stay with me. We are going to store sine theta also in one of the memory spaces. So I enter sine theta, which is sine 12, and I store this. So shift RCL to store, and I store this in B. Okay, so now in our possible answers, every power of sine theta is a power of B, because my sine theta is now equal to B. So if I see sine theta, negative 3 sine theta, this is in essence A. Option A is in essence negative 3b minus 4b cubed, because b is equal to sine theta. Option B is 3b minus 4b cubed. Option C is negative 4b minus 3b cubed. And then option D is 4b minus 3b cubed. So we know sine 3 theta, it's been stored in variable A. It's been stored in variable A. I can quickly recall A by pressing A, enter. So you can write this on your answer sheet somewhere, 0.5877, 0.5877. And then we are going to evaluate A, B, C, and D and see which answer and see which of these options will give us 0.5877. So quickly we type negative 3b. So we try option A. Negative 3, you can access B. B is in red, so alpha and then B. Negative 3b minus 4b cubed. This does not give us 0.5877. So we try option B. 3b minus 4b cubed. So b and then cubed. This gives us 0.5877. So we do not even go on further. Our answer is B. B. Next question. Express cos 4 theta as powers of cos theta. So you can pause this video and then try and evaluate it on your own. So this is what you're going to do. All your answers are in powers of cos theta. So we pick a theta. I stick with a 12. So I find my cos 12. So these are going to be what I get here. I'm going to save my cos 12 into my calculator's memory space B. So to evaluate option A, this will be b raised to the power 4 minus 8b squared plus 1. This will be 8b raised to the power 4 plus 8b squared plus 1. This is 8b raised to the power 4 minus 8b squared plus 1, on and on and on. And then I'll store cos 4 theta in variable A. Cos 4, my theta is still 12, so cos 4 12 inside variable A. And then I will evaluate. We know that cos 4 theta or cos 4 12. Let's quickly evaluate that. So cosine of 4 times 12, 0.669. Let's just write this somewhere, 0.669. So one of these answers should give us 0.669 when we are using B. So we quickly evaluate A. A is b raised to the power 4 minus 8b squared plus 1. This does not give us our 0.669, so we keep going. 8. Okay, let me just modify this. So I use left or right to edit my previous input. So option B is 8b raised to the power 4 and then plus 8b squared and then plus 1. This does not give me 0.669, so I go to option C, 8b raised to the power 4 and then minus 8b squared plus 1. This gives me 0.669, so I end here. My answer is option C. Next question. So just like we've been doing, we've been given sine 4 theta is equal to all of this. Express tan 4 theta as powers of tan theta. So we are going to ignore all of this. All we are focusing on is that tan 4 theta is equal to one of these. So we will pick our theta to be 12 and then find tan 4 theta. So tan 4 theta, our theta is 12, gives us 1.111. So 1.111. So after evaluating all of these, one of these should give us 1.111. The option that gives us 1.111 is our final answer. So they are all powers of tan theta. So we are going to store tan theta into our variable b so that the powers of tan theta will be powers of b. So for instance, 4 tan cube of theta will be 4b cubed. It makes our evaluation very simple. So we are going to store tan theta or tan 12 into variable b. So we say tan 12 bracket close. This is our variable b. So store shift RCL and then b. So 0.212. We don't care about this. We are going to use this in our options evaluation. This is b. So a says 4b minus 4b cubed all over 1 minus 6b squared plus b raised to the power 4. The cool thing is that after entering option A, we can keep modifying option A so that it fits options B, C, and D. So let's see how we do that. So option A is 4b minus 4b cubed over 1 minus 6b squared and then plus b raised to the power 4. Okay, so luckily option A gives us the answer we want, 1.111. So there's no need to go through options B, C, and D. Sometimes you get lucky, your first option is the answer you are looking for. So our answer is option A. No need to go through B, C, and D. No need, absolutely no need. So question 10 says, which of the following is a solution of z cube equals 4? Meaning one of these options is z, okay? This is our complex number, z is our complex number. So we are to find z. We know that z, for starters, we know that z is equal to 4 raised to the power 1 over 3. So in essence, our complex number is a certain complex number whose magnitude is 4 raised to the power 1 over 3 and whose argument, when you have any real number, say 3 is a complex number whose argument is 0 degrees, meaning that we are going to have a complex number whose argument is 0 degrees. So we are looking for a complex number whose magnitude is 4 raised to the power 1 over 3 and whose argument is 0 degrees. Now take note, the key word is argument. When we look through all of these options, we can see that for A and C, the magnitudes of these complex numbers are not even 4 raised to the power 1 over 3. So we are going to do elimination. A and C are out. We won't even evaluate A and C. So the contest is between B and D. Now here is the trick. The question says that z cubed is equal to 4. Meaning that if we cube B or if you cube D, we expect to get 4 angle 0 degrees. Cubing the whole thing means that you are cubing 4 raised to the power 1 over 3. The cube of 4 raised to the power 1 over 3 is 4. So we expect that the cube of B or D will give us 4 angle 0 degrees. Now, how do you cube a complex number? We've gone over it in our previous video and even in a previous question. So REI theta to the power n is simply RNEI theta n, meaning our magnitude raised to the power n and our angle multiplied by n. So we are cubing this. Our n is 3. So r cubed and then our argument multiplied by 3. Now, if you take this, let me clear this space. Now, cubing 4, we won't bother ourselves with 4 raised to the power 1 over 3 because if we cube this, we are going to get 4. So we'll focus on the complex part. We'll go to our calculator and then we will find the argument of this part. So it's half minus root 3 over 2i. So we convert this to polar and the argument of this is negative 60 degrees. So we will multiply negative 60. We multiply our arguments, we raise our magnitude to 3 and then we multiply our argument. We multiply our original arguments by 3. Okay, so our argument is negative 60. So negative 60 times 3, this gives us negative 180 degrees. Now option D, the only difference between option D and option B is the minus here. So negative of this. And then we convert this to polar to find the argument. So the argument is negative 120. So negative 120 times 3, this gives us negative 360 degrees. So we were expecting 4 with an argument of 0 degrees. But unfortunately, we have negative 180 and negative 360. So which of these is our answer? Well, you know that complex numbers can be represented on the Cartesian plane, right? So if a complex number can be represented on a Cartesian plane, and if real numbers are numbers lying on the x-axis, meaning having an angle of 0 degrees with the positive x-axis, then it means that as long as the angle between the x-axis is 0 degrees, we have a real number. So if we add one circle to 0 degrees, so we are on 0 degrees and we move one circle, we end up at 360 degrees, but 360 degrees also in essence has an angle of 0 degrees for the x-axis. So if we keep adding circles to our 0 degrees, 360 degrees is in essence the same as 0 degrees. 720 degrees, which is a second circle, is the same as 0 degrees, and so on and so forth. So our negative 180 degrees means that we are going counterclockwise. So from the positive x-axis, this is negative 180 degrees. This is not what we want. This gives us negative 4. 4 angle negative 180 degrees is the same as negative 4. That's not what we want. But we have 4 angle negative 360 degrees. So 4 angle negative 360 degrees. So we are going one whole circle but counterclockwise. We still end up at 0 degrees, meaning negative 360 degrees is the same as our 0 degrees. So in essence, D is our answer because it was D that gave us negative 360 degrees. So when we raised this number to the power 3, we had 4 angle negative 360 degrees, which is the same as 4 angle 0, which is the same as what our question gives us, 4 angle 0. Row number 4 is the same as 4 angle 0. So our final answer is option D. Next question. Next question says that the cube root of 2 plus 2i are as follows except. So meaning that all of these are cube roots of 2 plus 2i except one. So our question says we are to find the cube root of 2 plus 2i. So 2 plus 2i raised to the power 1 over 3. So just like we did for the earlier question, we'll quickly use our calculator to convert 2 plus 2i to we'll convert it to the polar form. So we have r and then the angle, and then we'll raise our r to 1 over 3, and then we'll multiply our angle by 1 over 3. So let's quickly find that. So 2 plus 2i, 2 plus 2i, we convert this complex to polar form. So our r is 2 root 2. You know, 2 root 2 raised to the power 1 over 3. And then the argument is 45 degrees. Now, as you can see, the pi we have here gives an indication that our operation or our complex number here is in radians. So we have to switch to radians. So 4, switch to radians. And then our argument is now pi on 4. So pi on 4 times 1 over 3. Now pi on 4 times 1 over 3 gives us pi on 12. So this is our base argument. I call this base argument because there are multiple roots, and these other roots are simply other versions of our base argument. So it's just the angle that's going to vary. So our magnitude should be 2 root 2 raised to the power 1 over 3. 2 root 2 raised to the power 1 over 3. And this is I believe this is 8 raised to the power 1 over 6. Let me raise this to the power 8, and let me raise this to the power 6 rather. So meaning this is 8 raised to the power 6. 8 raised to the power 1 over 6 as we have in our question. 8 raised to the power 1 over 6. Yep. So our 2 root 2 raised to the power 1 over 3, 8 raised to the power 1 over 6. So all these are possible roots except for one. So the angle is what's going to make the difference. Now we are going to, let's see how we will find the other sisters or brothers of pi on 12 and see which of these does not fit. Now how do we know the other versions of this pi on 12? Now the other roots are simply, like I said earlier, cube roots. Cube means 3. So we are going to keep adding pi on 3. If this was square root, we would keep adding pi on 2 to this angle. So we're going to keep adding pi on 3 to this angle until we find out that indeed one of these does not fit, or one of these is not a sister or a brother to our pi on 12 argument. Argument is like the base angle. So we start with this and we keep adding pi on 3. So we start with pi on 12. Pi on 12. Of course, pi on 12 itself is here. So b itself is one of the roots. So pi on 12, and then we keep adding. So I put this into answer and I say plus pi on 3 because it's cube root. So pi on 3. So 5 pi on 12. Well, we don't have 5 pi on 12 here. So we keep going. When I press answer, it's going to add pi on 3 to my existing answer. So 3 pi on 4. 3 pi on 4 is also here. So 3 pi on 4. I keep going. 13 pi on 12, not here. 17 pi on 12. This is also here. So we can at this point stop because we know that this is the odd one out. So our answer is going to be C. So the cube root of 2 plus 2i are all of these but C. And the answer is looking for the exception. So our answer is C. Thank you very much for watching this video. We hope you found this helpful. These were selected questions. So your Math 151 algebra test is going to be variations of one of these questions. We hope you found this very useful. Thank you very much. Do well to like our videos and subscribe. Peace.